validation of your food safety program. All food businesses are required to have a food safety program. And that's, Tracy?
Not in the territory.
Not Northern Territory?
No.
The only people who are required to have food safety programs under NT legislation and the Food Standards Code are the vulnerable population group, which are the hotels, nursing homes, hospitals, and childcare centres.
Right. Okay, so...
Plus a couple of others like seafood processing and a few other primary product.
Okay. All food businesses should be required to have a food safety program. Okay. A food safety, we'll go back a step. A food safety program is everything. It's not microbial, it's looking at the control points in your business that could affect the quality, but especially the safety of the food. So that's everything. Pesticide, if you've got, not pesticide, insecticide, what have you got for pest control? You've got storage of your fruit, vegetable. Do you have a pest, and a lot of it you're doing anyway in some form or another. But there's that, do you put baits out, do you, all that sort of stuff. The cleaning, how do you clean, your thing. Have you got refrigerators? Are they monitored? What's the temperature of your refrigerators? Are they between 1 and 5 degrees? What temperature do they run at? So for all of those things you should look at to control the quality of your product. And you're doing some of it, if not all of it, now. It's just not in a big book that says food safety program. But you need to be, and it looks at all the control points. There's this thing of HACCP. You've heard of HACCP? The hazard analysis of critical control points, the critical control points. Food safety program is taken out the C. It's the control of all control points. So all your fridges, all your freezers. If you get delivered frozen food, what controls are you doing to make sure it's frozen? And that can be simply opening up and pressing against the side of it, that's fine. But all of those things you need to evaluate because it affects your final product. So if you've got a food safety, and so let's just say in some form or another, all the food producers here have a food safety program. Because you do. It's not formalised, but you do have certain steps that you're putting. When you have a food safety program, via the FANZANS, Food Standards Australia and New Zealand, you must then validate that it actually works. And the only way for that to be done is to get the safety side of things checked at the end of it. So, if you're cooking burgers or whatever and you measure the temperature of the core thing once a month and the rest of the time, 1 in 50 burgers you break open to make sure there's no juice, that's part of that program. You still need to prove that the product that's coming out the other end is not going to make people sick. That's what's called validating your food safety program. And really, it can only be done by laboratory testing. When you're doing that, a set of analyses need to be performed, obviously. Now, there are primarily 2 standards in Australia, in the rest of Australia that we use, which is the Food Standards Code, which used to be section 1.6.1, which listed them all. It's now broken off into schedule 27 of that standard. And there's also the new replacement. There used to be a thing called the ready-to-eat food guidelines. That's been replaced by the compendium of microbiological criteria of food, because they thought that was a more official sounding term, which is only just coming up in 2016. Foods with a use by or best before date are supposed to meet those guidelines. what most places will do is they'll validate their food safety program and at the same time do their shelf life testing. And I'll talk about shelf life testing and whacking that date on in a moment. If a food group is specifically in that food standards code, then that's fine. That's Schedule 27, that's what we run by. If not, pretty much all the food that's made and whatever comes under that second compendium. But the Food Standards Code doesn't cover just about everything that you come across on a daily basis, whether you're an EHO or a food producer. Pretty much everything you're talking about, it falls under the compendium of ready-to-eat food. Okay, all of those things. This is just a dump, and certainly don't need you to look at it any way. But this is the sorts of foods that are in the Food Standards Code. Now Schedule 27. So they've got mollusks, they've got cereals, infant formula, some of your spices, coconut, cocoa powder, processed egg. It's very specific and very tight. But it will notice that they do state that mineral water, and packaged ice is in the Food Standards Code. And as you can see, the only requirement for packaged water and packaged ice is E. coli. And that's regarded, those three products are regarded as a food. Okay? When we look at that compendium, which is guidelines for everybody really basically should be using to evaluate the quality of their food, there's three groups. There's the spoilage organisms, the indicator organisms, and the straight food pathogens. Okay? Spoilage organisms are basically that mesophilic plate count or heterotrophic plate count, and we just cut it back down to just being a plate count. That's the only group in the spoilage organisms that appears in the compendium. Indicator organisms, they list two. There's E. coli and Enterobacteriaceae. Enterobacteriaceae, I probably wouldn't recommend people necessarily doing. It's very European. It's come out of Europe and we've dumped it in. You can do E. coli as a quite reasonable indicator of, and basically what E. coli specifically is an indicator of fecal contamination from warm-blooded animals. Pretty much all warm-blooded animals have E. coli, not fecal coliforms, in their feces. So that's why it's used as an indicator that, hey, there could be something going on. So if we look at a group of all bacteria, and we look at maybe, let's call a group aerobic, not fastidious, so they don't require special growth conditions or media or temperature. That's what that SPC or plate count group would do. Notably, things like Campylobacter, Clostridium perfringens, which are in the Food Standards Compendium, they don't grow on a plate count. They're not included. We go into the next subgroup down is Enterobacteriaceae, and notably a number of the bugs that we're looking for as pathogens aren't in that group. So Bacillus cereus, Vibrio parahemolyticus, Listeria monocytogenes, and staph, golden staph, if you listen to TV and media, and for everybody else it's what we call coagulase positive staph or Staph aureus.
Can I just ask you, this might be really basic, but when you talk about aerobic, you mean in the air?
Yeah, well, when we say aerobic bacteria, we're talking about the conditions that we incubate them in. So there's aerobic bacteria will grow in the air on an agar plate, not floating. And the opposite of that is anaerobic bacteria. They require, and there's another group called microphilic, but they're the ones that need to be into a special environment. So we set up a canister where we reduce the oxygen, increase carbon dioxide and nitrogen, and they're called anaerobic.
So you're actually talking about your testing process, not that these bugs are floating.
No. These aren't floating as in air. But
excellent.
Yeah. Yeah, I never thought of it that way, but it makes perfect sense. Great question. Inside Enterobacteriaceae, there's coliforms, and notably Salmonella is not a coliform. Inside coliforms, there's fecal coliforms. Coliforms could be broken into fecal coliforms and non-fecal coliforms. We don't ever talk about or use non-fecal coliforms. We only talk about the fecal coliforms. And inside fecal coliforms, there's E. coli. So there's no point, if you can't get a count for E. coli higher than a count for fecal coliforms, or a count for E. coli that's higher than coliforms, because that group's inside that larger group. Yeah?
Where does enterococci sit? Because I know that we did some testing on that, but I'm not sure, is that more environmental?
Yeah, enterococci used to be called Streptococcus faecalis, and now we've renamed to Enterococcus faecalis. Very prevalent in floodwaters, in fecal matter, often used in the environment. It's along with staph, so it's aerobic and staphylococcus. They don't tend to go testing for it in the food industry, but it's certainly an environmental bug. Or in recreational water. A lot of the triathlons and that sort of stuff, there are, by the National Health Medical Research Council, there's guidelines, less than 35, I think it is 35 per 100 mils. It's an acceptable level for recreational use of water, where there's going to be head
We
immersion.
get combinations of, I guess, that sort of testing when we go to camps and
Yep.
campsites.
Yeah, when you're looking at swimming pool, or not swimming pools, but lakes and streams, yep, there are specific standards for, there's separate swimming pools and spa pool requirements, that small plate count, Pseudomonas aeruginosa, really for that water. For recreational waters, it's pretty much now, it used to be fecal coliforms and enterococci, they really tended to drop out the fecal coliforms and go straight to enterococci as the guideline. So and that's right, especially when you go to camps and stuff, and they find that further upriver there's someone dumping sewage into it. There's in fact shouldn't be swimming, or there should be signs up that there's no head immersion, because there's different levels allowed for head immersion and just wading. Okay, and that also goes through like irrigation water. Is another one with the water type thing. Irrigation water, depending on if it's trickle or it's coming in direct contact with crops. And in that case, it's only fecal coliforms. It's not enterococci, it's only fecal coliforms, and there's different levels allowable depending on if there's direct contact with crops or it's a spray, grasses. There's about 5 or 6 categories. Okay, everyone happy with that? So we've gone through, that's the whole group now, and we've got the indicator organisms being E. coli and Enterobacteriaceae. And then you've got the food pathogens. As per all the bugs listed there, Gradulase positive staph, Clostridium perfringens, which originally was causes notable in World War I, causes gas gangrene. That's the bug that causes that. Also is a toxigenic strain that gets into food and can cause food poisoning. Bacillus cereus, Campylobacter, Salmonella, Listeria monocytogenes, and Vibrio parahemolyticus, which is only worthwhile looking for in seafood. Okay, this is just a dump, and you've all got this compendium, or this section of that compendium in your notes. But it basically, we're looking at this mesophilic plate count. The important thing, and again, that's just a plate count. All of these things, there's no difference from what we call that aerobic bacteria. Notably, it's got to be grown in the lab at 30 degrees. If anyone's getting food testing done at the moment, you need to get back from the laboratory what is their time period and their temperature for incubation for their plate counts. It must be 3 days at 30 degrees. Not 2 days at 37, which is what we use in water. In Australia, it's got to be 3 days at 30 degrees. That way you're picking up not only the hygiene type bugs, you're also picking up the food spoilage bugs. It's one of the rare cases where Australia is actually leading the world in doing something right. In the US, they just did the 2 days at 35 and they're not picking up any of the spoilage organisms. People are wondering why, even though it's passing, their product's going slimy before the end of that shelf life. Inside the ready-to-eat guide, it basically has 4 groups, and it talks about the acceptable plate counts for each of those groups and of those acceptable levels. And I won't go through them, but obviously when you're looking at less cooking, less processing, more handling, it's allowing a lot higher level of bacteria. Okay, and then there's the group which is down the bottom, which is all of your fresh fruit and vegetables, salad type sandwiches, dried foods. Don't do a plate count. There is no point. You can do it for your own interest to give you a feel of how my process is working, but you can't interpret those results. There is no acceptable level. So don't ask people to do it. Don't ask people to do plate counts of their sandwiches and rolls or any food in that final category, because you can't say it's a pass or a fail. You can't interpret the results. Okay? When we're looking at the indicator organisms, Enterobacteriaceae, you're basically really only looking at that satisfactory level. You can have a look at the rest, but that's what you're supposed to be reading. If you're doing Enterobacteriaceae, it should be less than 100. If you're doing E. coli, it's got to be less than 3 per gram. If you're doing testing at the moment and you're getting back results from a laboratory and it's got on the report less than 10, that's very interesting, but it's not a pass of the Food Standards Code. And I don't care whether or not you have to meet it or not, you have the right to get the quality results from the laboratory you're using, so you have to, and it's a standard method, you have to be getting less than 3 for E. coli, or it's a fail. If you get less than 10, it could be a fail, but it's certainly not a proven pass. Okay? And with the pathogens, and I won't go through all of them, they basically, for all the counts, less than 100 count for all your straight pathogens, Clostridium bacillus and staph, less than 100 is acceptable. For your Listeria mono, Salmonella and Campylobacter, its absence in 25 grams is what's required. The only weird thing is the Listeria monocytogenes. If you can prove your food does not support the growth of Listeria, then they will take an acceptable level is a count of less than 100. But most foods you can't. You've got to have a low water activity, low pH before you can prove it won't support the growth. So for most places, and just about all ready-to-eat foods, maybe your dried fruit mango may fall into that category. But for most other things, yeah, you just have to have less than 100. You have to have not detected in 25 grams for Listeria monocytogenes.